Hello, everyone. Welcome to the third iteration of Dan's Data Office Hours. I like to think I'm getting better at this, trying to figure out the entire LinkedIn and Zoom streaming, but I've been a bit busy past couple of weeks. But I'm hoping to actually do a bunch of experimentation before the next session. So call me out on if I don't, but I'm going to try to give OBS a shot. So it's Open Broadcast Studio. And the thinking there is I could do actual overlays to show, for example, the questions being asked really on the footer, or and to share my screen a bit better because I realize me talking for 30 minutes like isn't the most engaging, especially if you're jumping in, halfway through and then you're like, what's he talking about? So I want to give that an actual shot and maybe do some editing. So we'll see. Obviously, feedback's all welcome. So if you have anything you want to suggest or recommend, I will gladly hear it. Other thing to mention is please leave feel free to ask comments or questions live. You can do it in text through the Zoom. There's a Zoom link in one of the comments. There's also a way for you to ask comments in the link section. I'll check that about halfway through just to make sure I don't miss anything. And then the last thing I want to say is there's actually someone submitted a question ahead of time, anonymous, but it's an actual data modeling coding question. So that's exciting, right? Because to date, I've only been talking about high level themes and trends and thoughts. So this will be a good way of, sharing my screen, showing some of the SQL, explaining some of the concepts. And I'm like fundamentally, it's like my goal here is to provide some value, and part of it is, as I say, is the best way to learn is to teach. So I'm hoping that as people ask questions, as I try to explain things, I myself will learn and get better and better. Cool. So without further ado, there's a question asked last time I didn't get to, and it was asked by Jason, and so I'm reading it now. So you spoke a lot about data modeling, architecture, etc. Anything catch your eye in the analytics, visualization, insight layer? And like I love this question because it's something I've been spending a ton of time thinking about, and I wanted to actually share my screen a little bit in order to show um, the like a chart that sort of explains at least how I'm thinking about the space. So this is a diagram. Let me share my screen here. Full screen. Yeah, so this is a chart from this Andreessen Horowitz post. It was initially written in 2020, but they've updated the chart since then. But I really like this diagram explaining. Let me see if I can even, the Zoom doesn't work. But I love the idea here, right, of explaining really the landscape of the different tools we have and or the different approach to different technologies and like what is in each layer. So this course in particular was talking about this layer here, right? This transformation piece, right? The metrics layer, data modeling, and workflow management. So I was going to dig in there and explain how I guess my general thoughts here and how it fits in with both analysis, but also the I would say like the prior layers. One good thought to have here is like to approach a lot of this also from the standpoint of like, these are, oftentimes real businesses running companies in each of these elements, and they have an incentive to do what's best for them, not necessarily what's an incentive for the overall market. The way I've been phrasing it is that the modern data landscape tends to be a lot of local maxima. And if you were to, redesign from scratch, blow it all up, it would look very different. And maybe it happens over time, maybe not. But that tends to be, and I'll give an example of that as I talk through about some thoughts around the sort of like, in particular, this like metrics, semantic BI layer. So let me pull up. Yeah, so one of the biggest things that I wanted to talk about here, and a trend at least that I've seen, is the relationship between the BI layer and the semantic layer. So if you think about it, if you think about this landscape we just looked at, you do a lot of the transformation, you have the data, you're grouping it together, you're joining in order to create these new tables. And then separately, you have what people call the semantic layer, which is really the definitions for the metrics. Like how do you define revenue? How do you define market share? How do you find retention? How do you define churn? And the reason it's important is it's like you can't always put it upstream, right? You can't always put it up into a table. Like instead, it happens to be something you have to derive, calculate at query time. And if you're running a company or a team, you want to have consistent definitions throughout. So there's this trend where the BI tools, right? So really what's really exposing you to the like to users, right? To dashboards, visualizations, queries, like they're trying to absorb the BI layer or the semantic layer into them. So think something like Looker. Looker has LookML, and in that case, you're trying to like Looker's trying to get you to say, you know what, keep all this logic around all these like really was it like critical definitions like in our system, and then we're able to dynamically write the queries and go back and hit your database data warehouse in order to generate these dashboards. There's another solution here which I really like philosophically like called cube.dev, and they're trying to be this like open semantic layer, meaning that they're not going to be tied to any BI tool, but instead they're saying you define your metrics, like definitions in our sort of service, and then we will then propagate it in or let other BI tools use it. Similarly, they'll also let you access these definitions in like your data science. Let's say like a Jupyter notebook, you're able to make sure that data scientists have the same definitions that your data analysts do. Same thing with applications. Like if you have a specific application, like you want to have the same definitions for churn that everyone else has. And but the implication of that, right, is if the semantic layer of these definitions sort of shift away from the BI tool, then the BI tools needs to get lighter. So there's like a pretty strong incentive for BI tools to actually make have more and more lock-in by trying to do more and more, or like capture more and more of this value. So like one example could be like one stack may end up being you only have a BI tool, and then you have, let's say, a data model powered by DBT or SQL Mesh, and you don't really have this idea of semantic layer just absorbed into um, the BI layer. Alternatively, you can imagine a world, and actually like this model too. There's a post here, and I could share later, or maybe I'll share it. Yeah, let me actually share my screen quickly. But it's written by Maxime, who created Airflow and Superset, and the concept he calls entity-centric data modeling for analytics. And the key point here is instead of you trying to define all these, I'm simplifying it like significantly, but instead of trying to define metrics way downstream, try to put them up into your data model. Right. So in the case, I think the example he gives here is, let's say you're Facebook and you want to collect stats around users. When was how many logins did they have in the past week? How many logins did they have in the past 4 weeks? Like instead of calculating at query time, you would actually have a table called user stats, and it would have columns for logins 7 days, logins 28 days. And in that way, you're calculating the metrics once, and then you're able to reuse the same exact definitions across every single use case, right? So it's efficient from the standpoint of, compute it once, and you guarantee that people are going to have the same metrics or the same definitions throughout. Obviously, the trade-off there is, well, I want to calculate, user logins in the past, 22 days, like then you have to go back to the source. But there's something here around pushing sort of like the semantic layer further away, right, from the BI tool and actually going closer to the data. So I just think there's like something interesting here, and it's not clear how it plays out. It's very possible, like what I suspect happens is you're going to have different pockets of tools that work nicely together. So like Looker and Cube.dev, like it seems it's very unlikely they're ever going to work nicely together. But if you take like a lighter layer BI tool, maybe like a Lightdash, like that does work nicely within like a Cube.dev. So I think you'll end up with these like yeah, going back to like these pockets or groups, clusters of tools that work nicely together. And it's really going to be a question of, philosophy of the team and around the, like what they actually care about. And that's going to influence how they make some of these decisions. So that's that. Let me see if there's another follow-up here. If there's another question. Yeah, I guess one thing I wanted to add to this, AI is the whole other world here, right? How does AI fit into this? And I spoke about it, I want to say either last session or the one before, but there's like everyone's dream is to be able to say, I want to have this AI agent that I could ask anything in English or, the language I speak and get back nice, actionable, clear results. And there's a few sort of solutions here. And I think fundamentally the big, like the real differentiation is really about how much do you trust AI here. So there's a company called Seek.ai, and their big thing is like, we're going to put a human in the loop to validate all the query results that are, or all the queries that are generated by our sort of LLM solution. Then you have a company like Zenlytic, and they're saying you define the semantic layer, right? These definitions in code, but then we will use LLMs on top to write the query and surface or to use these official definitions, but write a query to, let you look at things over time or look at things across like different dimensions, different groups, right? So it's generally low risk that they're going to sort of, yeah, it's generally low risk. It's going to hallucinate queries. Instead, it's going to maybe hallucinate some of the query part, but at least the metrics is going to be, his metric is going to be correct. Another layer, there's a company called TextQL, and they're trying to be, just trust AI fully. We're going to invest in like ontology and all the relationships in order to guarantee or like, make sure that the quality is as it is. I think the last one, there's also a big trend, like a trend I'm seeing where you'll have team specific agents. So maybe you don't have, let's say, an AI tool, like an AI BI tool for the entire company, but the finance team has one. The marketing team has one, the sales team has one. They all have their own goals and their own like data sets. And my sense is it does make things a bit easier, or I would say more like reasonable, more likely that these solutions would work when they're focused on, I would say, like a specific vertical, right? Because they have enough context. Like, what does finance care about? Like, then you're also familiar with the type of data they look at, the metrics they have. How do you calculate revenue? Like, do you know a sense of like accounting principles like GAAP? And I think by focusing on specific verticals, we may end up in a world where, similar to how different teams have different BI tools, now you'll have different teams having their own sort of like BI or like AI agents. So another question from Jason. It was, what was a talk model thesis, major point that you completely disagreed with at Data Council? This is a bit of a bias here because I generally only attend the talks I was curious, interested in, and there's going to be a bit of a softball answer. But I did think a talk that made me think a lot was by Colleen Tardo, titled "The Realities of Building a Modern AI Data Stack." So her premise was that AI is so different from the rest of the data that we need to treat it accordingly. So my first take was, I don't know, it's like, is AI that big of a deal? Like, obviously, we're all using ChatGPT and it's impressive, but from like an underlying technology standpoint, like I get that there's models, but whatever, just throw GPUs at it. Like, I just didn't really get a sense of why it was fundamentally different. But as I listened to it, I did get, swayed. I wouldn't say fully convinced, but I did get swayed. And one of the points she makes, and I'll throw up this slide in a sec, is if you actually look at, maybe I'll pull it up right now. So let me pull it up right now. It's on the data council schedule, so I could also send that around. Right, so it was by Colleen. There we go. The realities of building a modern AI data stack. And if we look at the slides, so one of the slides here was, let's see if I can dig it up. I have this one here. Right, so the way she phrased that I really liked is if you look at, I would say, traditional sort of data she phrased BI versus AI, like it varies across a lot of different dimensions. One is obviously the data type. Like typically when we're working with BI tools, it's structured, semi-structured data. Like AI is like, images and just blog posts and just straight up text. Volumes, just complete order of magnitude difference. Complexity, at least these days, is much higher. Like real time, especially if you're building, going back to this like consumption patterns, if you have machines that are ingesting some of this output, you also want to have it be real time in order to like act. Think of robotics. Like everyone's like these days, a lot of people are about how robotics is going to be revolutionized with the rise of AI. And in that case, you're dealing with the real world, but you also need to, serve and respond and sort of like process data in real time to make these robots actually effective. Right? Value, like our point is like it's still relatively new. We're figuring it out. Governance, like same thing here. It's like it's a very mature industry here. We're all still figuring it out. And infrastructure is the big one, right? Just saying initially we have generally, commodity solutions here, general compute, but now there's going to be much more investment in compute, especially hardware. And it got me thinking, because like I do think there's some truth to it. Maybe it's a bit overplayed, but like I do think fundamentally as we get deeper and deeper into AI, we'll all catch up and we'll figure out how to work with it. But right now, it does seem to be a bit of a different beast. The other points she made that surprised me is there's been this shift. If you have a company right now and you're a startup, you're going to build on the cloud. Right? You're not going to have your own hardware, your own data center. And you have larger companies that these days are still in their migration to the cloud. Like not for sure, not 100% what they're doing. They're going to migrate more and more workloads when it makes sense to do so. Her point was, hey, actually, the world of AI is so expensive computationally now that you actually see the reverse movement. You'll see these larger, the largest companies actually moving the data back away from the cloud into their own like data centers that already have GPUs, really from like a cost performance standpoint. And I just thought that was just like a very interesting take that disagreed, I would say, with like my initial assumptions, my initial thoughts. Let me check the LinkedIn events page just to make sure that I didn't miss any questions because I know that happened last time. So hold on for a sec. Check the okay. No comments yet. Great. Okay. So the last question I had prepared was by an anonymous source. Didn't want to mention it, but this is something I'll actually screen share. So let me put up my screen. Yeah, so the question was a data modeling question. It says, assuming I receive a batch data daily from two separate sources for the same entity, each data source contains two dimensions, date and country, and one metric, revenue or clicks. The data and country values are the same across both data sources. These two data sources have significant overlap in terms of data country combinations, but not identical. Same someday some country may not have revenue and vice versa. I'm considering how to architect the table view to combine the data efficiently. So there's a few different sort of sub-questions here. One, should these two data sets land in the same table? If yes, do I need to consolidate the data regularly? If not, to combine the data, should I use union all or full outer join? How to weigh the options. I also have one add-on to my data scenario. What if the revenue table data has one extra dimension, e.g. device, still worth it to hold all data in one big table? Intuitively, I feel not. Setting device as null for clicks seem cumbersome. So great. It's a technical question. And to answer, I would say a lot of it does depend on the context, right? What are you trying to do with the data? Like in this case, it does make it seem that we have this time series data, right? So we have two different reports. Like I'm basically like I'm sure there's a simplified version, but you can imagine you will have two different data sources coming in. They both have date country or anything really. Right? It could be date and I don't know publisher, date and brand, and a set of metrics. And you want to figure out like how do we combine them into a single sort of data set. So the way I would generally think about it is like it makes a ton of sense for me to combine them in the same table mostly because I suspect the type of analysis you're going to want to do here is going to require the data to be co-located. And there's something nice, right, about creating like this one wide table that you could then use for a variety of purposes rather than having to go back to the underlying source. So my answer is like for sure, it seems very intuitive, especially if the grain, meaning like the dimensions, match between the two tables, right? In this case, data and country are the dimensions, what the tables are going to be unique by. It's pretty intuitive for me to say, you know what? Yeah, let's just create a very wide table that has revenue and clicks. And in this case, I would be thoughtful around like, should it be, should it be null or should it be zero? So like the example here, like assuming it's like you would do something like this, right? From A, join B, on A dot date equals, let's do B dot date and A. Well, look at that. Copilot's fixing everything, right? So you could do something like this, right? Join, but there's an inner join, right? So we would instead want to do full outer join. The idea here being that, and that's actually what it was asked here, right? The idea here being that if you are doing it as a full outer join, then you're going to capture anything that's like if you think about a Venn diagram, it's going to capture everything, including things that are only in A or items that are only in B, right? But in this case, the query would need to be a bit more nuanced, right? You would have to do A dot date or whatever. It's good enough, right? All right, so there you go. You get something like this. But in this case, right, there's null values here. So we would both want to figure out exactly how we want to sort of handle it, right? Do we want to keep it as null? Do you want to keep it as zero? Like my intuition here is you'd actually want it to be zero probably, meaning like the existence of this. Like, and the reason I say that is you could imagine downstream from this, you're going to be doing quite a lot of processing. And if there's like a null value, you do, null plus 4, or grouping by, I don't know, country, you don't want it all of a sudden to give you like a null result. So I would just be explicit here and try to avoid nulls and just say, we don't have data for that, so the revenue was zero. But obviously it depends on the situation. Maybe you have a separate job that validates the data set after the fact and says, hey, we discovered that these countries have no revenue on these dates. And then either flag that for investigation or call it out to a vendor if the data is coming from a third party. So if we want to finish this query, I would actually do something like this. Um, as revenue, and do the same thing here. Go clicks, should have a comma, and then we'll do a group by 1, 2. So like that's this full outer joint solution here. The union all solution would be, let's see actually how ChatGPT does it, or Copilot will do it, union all approach. Yeah, there we go. So the issue here is that it would still be double counted, meaning like if there was right the like meaning that in this case if there were two, if there was a date country pair in each table, like this would give us basically give it to us as two separate rows. So like we would then need to combine it. I guess it has that. And I guess let's do this. Let's see if this would work. Oh yeah, this would also work same way. But here. So I guess the question here is like which approach is better? Like fundamentally, they're going to give you the same exact result at the end. And it's a question of like readability. I personally prefer this approach. It seems a little bit easier to me. Others would want to go with this one. And beyond that, I would also think about performance. Like I assume this example is sort of like a toy example with like a smaller data set. So I can't imagine, date, even if you look at, I don't know, data since, I don't know, 1900 in country, there just aren't that many. There's about 200 countries in the world. Let's say, and you look at how many days there are, 365 a year, multiplied by 100 years, like it's just not that much data. So either of these approaches would be fine. But as soon as you run into like real, like maybe there's, tens of millions, billions, I don't know, trillions of rows per day, like in that case, each of these will end up giving you pretty different performance. And that's just something I would want to test just to understand the trade-offs here. So then the last question, I also have one add-on for my data center. Yeah, so this gets pretty interesting, right? The question here is saying, actually, what if instead of this case, table, instead of table B, or sorry, I guess you use the example of table A. So instead of table A having, date, country, revenue, it also has date, country, device. Like in that case, what do you want to do? And it's a good question. Like, would I still create one table that has device with a null? Once again, it does depend on the use case that you're trying to do here, but my immediate reaction is very similar, like it matches the intuition here that it does not make sense to set null for clicks because it's like, what does that data, like, what would the resulting row actually mean, like in that table that we've created? The fact that you have nulls is like, what does it mean? And the other I would say like nuance here is you would have like if you look at like a maybe like a typical row, right? Like I don't know what this is trying to do, but let's say a sample row for A would be, you know, here, let's say today's April 12th. Let's say it would be, oh great, good example here. This is why Copilot is useful, right? So in this case, revenue was 100, device was desktop, clicks was 10. And if we didn't have desktop here, it's kind of obvious, right? Like we just have a new data set that has, this date, country US, 100 revenue, 10 clicks. But as soon as you add desktop here, and let's say you want to say, we're going to create a combined table, like what will it actually have, right? If we have like what columns would it have? Like, let's say it would have US. Like clearly in this case, we can't necessarily assume that this number of clicks, this 10, belongs to desktop. So like the question's asking, like this would be a null, and then you'd have this other row where this would be null, null, and then this would be 10, right? If assuming the columns here are date, country, right? So that's kind of what this is getting at. And like this just seems pretty ugly to me, right? Like why would you have a table that looks this way? Alternatively, you really could go in and say, you know what, actually, I really want to have this like single table. So one approach we could do is we could just get rid of device and basically collapse into this question, the same exact scenario we did before, right? We don't care necessarily at what level the data comes in as, so long as we're able to roll it up to the desired level, right? So in this case, so long as so long as date country exists across any tables we get, maybe there's another table called C, so long as that's date country, we could just roll every metric up to date country and create this table that has all the information by date by country. Obviously, that doesn't help this question of, well, I need device information. What if I want to filter by device? And then the question would be like, well, what do you need it for? Well, in that case, are you able to go, like using this example, like if all you care about is revenue for device, like you really could go back to table A. Like you don't need table B. But if the question becomes, you know what, I want to understand, revenue by I don't know, revenue or the ratio, let's say, of revenue divided by clicks by device and country. Like that's a bit tricky, right? Because in this case, we just don't know the split. One, maybe a simplistic approach you could do, and I'm gonna do an example instead of writing clear here, but one simplistic view would be like instead of and this I would say a pretty useful suggestion, like a general working with data. Get some sample rows, put into Excel, put into a spreadsheet, whatever it's called, Google Spreadsheets, Excel, and just poke around, like modify the data around, see what it looks like. Use a pivot table because a pivot table gives you, in essence, the same functionality as a lot of SQL group by statements. So in this case, you say, like, what do we want the resulting data to look at for, let's say, these two rows? Like we said, this one is a bit ugly. We don't want to deal with it. But you could go in and like, what you could do here is you could say, right? We could just say assume, like do a full join, meaning that just duplicate this data across every single row of A. But once again, like that's not great either. Because let's say we go 12 US, I know phone, whatever, mobile 50. Like in that case, this data set would look like this, right? It would be nice and simple. Like when you do a sum, you still get 150. When you do a sum of revenue, you get the 150, which is correct. When you do some clicks, you get 10. But if you're going to do like a naive join, then you may end up with something like this if you were right, if you're not being thoughtful. And like that's wrong because if you do sum of clicks here, you end up with 10 plus 10, 20, which is just no longer accurate. Alternatively, you could then say, well, if there's multiple rows of if I have rows, if I'm gonna have multiple rows for each date country pair and there's gonna be a device, I want to split the clicks, which does not have a device column, proportional, or let's say just based on the number of rows. So maybe one approach would be, you give it 5 and 5. Right. So then the total sum is still the same. You still get 10, but you just split across rows. But at the same time, it was a pretty arbitrary, right? Why would you say, it should be, split evenly just based on the pure number of rows? Like you could imagine there could be another row here where if this was 5, you say it doesn't make sense to give it, 5 clicks if the revenue is only 5. So another approach is maybe you could bias it or weight based on based on the 150, right? So in this case, you would say there was 10 clicks, so this is gonna be 100 times 150. Oh, sorry. Oh yeah, and this would be 10 times 50 over 150, right? So there's basically 2/3, right? So let's say 6.67, maybe round it to 7, and then this is 3 if you want to have it as an integer. So in that case, like, and I don't know, right? Like a lot of this would depend on the business use case, like what are you trying to do? But it's like doing any of these honestly is like a little dangerous. Like the problem with this one, it has too many nulls. The problem with this one is you're just double counting, like potentially like basically double counting clicks. Like this one, like these two is you're sort of arbitrarily splitting the clicks into other rows. And like I would just be very wary of these because it may work in the short term, but it's going to be one of those things that 6 months later you look at it and be whether it's another team, like let's say another team member joins your team, they'll be pretty confused. If you're going to be trying doing aggregation on this, you'll get confused. So I wouldn't I try to avoid anything that's not pretty explicit or obvious, unless you have like a really good sort of specific use case here. And then even then I would like document it and put notes, comments just to make sure that people don't get tripped up. Let me check another view on LinkedIn to see if there were any comments. And I do not think so. Okay, cool. So thank you everyone for joining. I will post this. Yeah, I'll add some comments to the video after this. And yeah, for next time, I'm going to give OBS a shot to try to make it a bit more, not necessarily interactive, but a bit more polished. And if you have any suggestions or recommendations for how I can do better, please ask. Also, please throw your questions here. Could be code, could be theory, could be data, could be anything. And thank you.